Good afternoon, everyone. My name is Martin, 9 Alpha 2 Juliet Kilo, and today's presentation is about FT8. Before we start, anyone is using FT8? Only one? Two, okay. The goal of this presentation is, what is FT8? Why is it so popular? How is it different from other digital modes? And a few words about FT4. And finally, make real QSOs. FT8 was developed about 5 years ago by Joe Taylor, Kilo 1 Juliet Tango, and Stephen Franke, Kilo 9 Alpha November, for making reliable QSOs under weak signal conditions. It is named after its developers, Franke and Taylor, FT. And number 8 denotes 8 frequency shift keying, so FT8. FT8 is made for poor conditions, weak signals, or signals inaudible to the human ear. Poor conditions include poor propagations, high noise, antenna restrictions, something like that. In the last 5 years, since its existence, FT8 has become the most popular modes of amateur radio communications. This is a picture data taken from clublog.org on the sample of over 329 millions of QSOs in the period of last 5 years. It clearly shows that more than half of FT8 QSOs were made by FT8. And then comes some CW and some SSB, and then the rest of the other modes. So, what makes FT8 most popular mode in the last 5 years? Everyone has its own reasons for that. But the important thing and proven fact is that we can make FT8 QSOs when with other modes it's not possible. And FT8 lets you work the world from a small or limited space and could decode the signals that we cannot hear by our ears. Comparing FT8 with other modes, first we compare by the bandwidth. The SSB bandwidth is about 2,700 Hertz. This is the frequency range, frequency spectrum occupied by the SSB mode. CW occupies about 100 to 250 Hertz depending on the speed. If the Morse code speed is higher, it takes more bandwidth. And FT8 is very narrow. It takes only 50 Hertz. What does it mean? Why this bandwidth is so important? In the frequency spectrum, for example, of SSB QSO, about 2,700 Hertz, we could have at least 10 or more CW QSOs at the same time without interfering with each other, or even 50 FT8 QSOs at the same time without interfering with each other. Another thing that is important is noise, because along with the signal, our receiver always receives the noise. And the noise is not information and is the greatest enemy of radio communication. If the noise is too high compared to the signal, we can no longer separate the signal from the noise. And in addition, noise can distort the signal and change the information that the radio wave carry. You have to understand that noise is not the same as interference, QRM, from the other stations. There are two types of noises, two types of noise, internal and external. Internal noise comes from the electronic components in our radios, such as resistor, transistor, etc., and there is nothing we can do about that. It is as it is. And the external noise could be atmospheric or industrial. Atmospheric noise comes from lightning and has the greatest impact on short wave, on the frequencies up to 30 megahertz. But worst noise nowadays is industrial noise. It comes from man-made electrical sources like switching mode power supplies in LED lights, battery chargers, computers, home appliances, TVs, everything that goes on electricity. The noise and the bandwidth is important when it comes to giving signal report in FT8. In SSB, we give signal report according to RS scale as readability and signal strength. For example, 5 by 9 means readability 5, signal strength 9, or signal strength 8, and so on. But in FT8, we give a report as a signal to noise ratio in decibels. And that signals to noise ratio is calculated automatically by the software, by the computer. For example, negative 16 dB is a report. And the most important thing about the noise is that you understand that the noise depends on the local source. So in each location, in each place, the intensity of the noise is different. Other things could be the same, but if the noise is different, the signal report is different. If the noise on the other location is too high, and the signal is still strong, sometimes even the computer will not be able to decode the signal. So the communication will not be possible. Here is a comparison of signal to noise ratios of different modes in the reference bandwidth of 2500 Hertz. SSB signal takes about 2700 Hertz. So the content of the noise in the spectrum, wide spectrum of 2700 Hertz is much higher than in the narrow signal, like for example FT8, who is only 50 Hertz wide. Less bandwidth, less noise. Less noise, better signal to noise ratio, better chance to decode the signal. So SSB signal has to be 10 decibel higher of the noise for us, people, human beings, to be able to receive it with our ears. But on the other hand, CW signals, because they are narrower, could be weaker, and we are still able to separate the signal from the noise with our ears, until we reach the level when we will not be able, because our ears and brain are limited, that we could not be able to separate signal from the noise. It is approximately of minus 15 dB signal to noise ratio. FT8 could be minus 21 signal to noise ratio, and computer is still able to decode that signals, but we are not able to decode it with our ears. Because, you know, when you listening on the band from loudspeakers, FT8 communication on SSB channel, you hear all the stations, stronger and weaker. But if the weaker are in the noise, in the signal to noise ratio of minus 1.5, minus 15 decibels, we are not able to hear them with our ears. So what is needed to operate FT8? We need normal SSB transceiver that we use for normal SSB communication. Actually, USB, upper sideband. We need a sound card in a PC, or if our station, there are some modern radio stations that have built-in sound card, we don't need separate. We are using that is built in our transceiver. And we need an audio interface to connect received audio from the radio into a computer, and audio output from the computer to the radio. Of course, computer with FT8 software, and indeed, believe me, we have to use the computer between our ears. Okay, I already told you about the transceiver. Sound card. FT8 is transmitted as analog signal in the audio frequency range of the human voice, between 300 Hz and 3000 Hz. After the receiver demodulates these tones, it sends them to the input of the sound card. Sound card makes analog to digital conversion and send these digital informations now to the computer and the software for further processing, because the computer can only process digital signals, digital information. On transmit, the software sends digital signals to the sound card. Again, sound card make conversion, but this time from digital to analog. And on the output of the sound card, we have analog signal, the tones that we can hear without ears, and send this analog signal to the transmitter, because our transmitter doesn't understand if we are talking to the microphone or taking audio signal from the sound card. The same thing if we are listening from the speaker or sending the signal that normally should go to the speaker to the sound card for digitizing and to the computer to further processing it. So in this picture, you may see how it could be made. I mean the connection, computer and the radio. This is the computer with sound card. This is our transceiver. Sometimes we may need an interface. If the radio has built-in sound card, we don't need this interface. We just need one simple USB cable. The same one that we use for example, connecting printers. Nothing special. And that's it. Okay, have to install the driver to the Windows, configure it, nothing complicated, believe me. Computer and software, normal PC running Windows 7 or later Microsoft operating systems, Windows 10, for example, Macintosh or Linux, because the software exists for all the major operating systems. And of course, faster machines are always better, nothing special about that. The original software for FT8 is WSJT, Weak Signal Jaw Tailor X. This is the name of the software. It's not fancy name, but it is the name. There is another software, such as JTDX or MSHV, but all those softwares are derived from the original WSJTX software. You may use whatever software you like, but here we will talk a little bit about original software. The next thing that is important is time synchronization. We have to have absolutely, not absolutely, but very precise time in our PC clock. And the Windows time is not correct. So we have to use special software that connects the PC to the time servers over the internet and correct the clock in the Windows. The software is free. One of very popular and very good is Meinberg NTP client. But there are others also free, so you have many softwares to choose from. All of them are working more or less the same. And you always may check your computer clock on the website. Just open the website time.is and the big screen will opens and telling you how many seconds or milliseconds your computer clock differs from the real time. The structure of the FT8 mode. FT8 is not a chat mode. FT8 is made for minimal contacts where we exchange three things: call signs, signal reports, and confirmation, and sometimes maybe a grid locator. Grid locator is not necessary, but okay. And we do not send character by character like in other modes. We are not typing on the keyboard and sending character by character. Instead, we send messages as fixed length packets. Those packets contain only basic information for the QSO, and error control data and synchronization data. Those informations are necessary for successful decoding. And for successful decoding, the receiver party, the other side of the QSO, must receive the full packet. If the full packet is not received, the computer is not able to decode the message. FT8 messages that we are sending are generated by the software. You just have to click on the call sign of the station that the computer is decoded and you want to call. The rest is the computer's job. And we exchange messages in synchronized time slots of 15 seconds each. So 15 seconds we are on receive, 15 seconds we transmit, 15 seconds receive, and so on. The operator initiates the call manually, clicking on the call sign of the station that he wants to make a QSO with, and the rest is the computer job. On this picture we see 3 time slots, 15 seconds every of these slots. But the message, length of the message is not 15 seconds. Length of every message is 12.6 seconds. The rest of 2.4 seconds is computer time, because after the receiving message, the computer needs time to decode it, because the computer starts decoding the message after the computer received the full message. So for example, that is why we need synchronization. If the station 2, for example, is too late, starts calling too late in this 15-second slot, there is not, maybe yes, maybe no, enough time for the computer to decode the message. You see, in this picture, there is time to receive the full message, but the computer is left with less time for his work, for the computer work. And if the station starts calling too early, this station calls when this station transmits. So there is no chance for this station to receive the message if this station starts calling too early. Okay? This is the main idea. It's not necessary for you to memorize that, but to understand why the time synchronization is really important. And I already told you that operator initiates the QSO manually, but exchange of the messages goes automatically till the end of the QSO. And how the software knows which message to send next in those exchange of the messages? Very simple. From the content of previously received message. Because all the protocol is made that way that the messages follows each other on the previously agreed protocol. And at the end of the QSO, the operator must manually log the QSO. That is the job of the operator. Start the QSO and log the QSO. Although there exists some software for automatic QSOs, but it will never make a quality and weak signal QSOs like an operator. So how the screen for the FT8 looks like? We have 2 windows. One window is waterfall and spectrograph, and this is the graphical user interface. We see all the decoding messages. On the left side, on the right side, there are other messages I will tell you now. But first, about the waterfall. On the waterfall, we visually see all the signals that we are receiving, and using the waterfall to find empty space to call CQ or other station. You see, those are signals. Those black hole is empty space. So we are never going to call over the other stations. We have to look for the empty space to call. Important thing to remember is that the software only decodes the signals we see on the waterfall. So The waterfall should be extended on the computer screen up to 3000 hertz or more, minimum. Otherwise, the signal that exists in our radio, the software will not decode. The scale at the top of the waterfall is audio frequency scale of the signals we see on the waterfall. We have two indicators. Red one is here, and green one. Red one is our transmitting frequency, and the green one is on the frequency of the station we have chosen with the mouse button. It is receiving frequency. The software decodes all the signals at once. We see all the signals that are on the waterfall. And we see that signals here. On this side, receive frequency decode window, we only see the signals under the green indicator, and we see messages that we transmit. The messages are colored for easier to find. Okay, any message with your call sign in the message is red color, red background color. The messages you transmit are yellow, like this one. Station calling CQ is green. And the software offers you many other options. So for example, you may have another color for, let's say, stations from another continent or whatever. There are many possibilities to choose from. But these three are most important. Calling CQ, messages you transmit, yellow, and red, the message with your call sign in it. So when someone calling you answer on your call, the message is red. Before calling a station, there are a few things you have to do. Okay, check antenna, connect transceiver, set up transceiver for a normal SSB operation. You have to turn off all signal processing functions on your transceiver, such as DSP, digital signal processing, noise reduction, noise blanker, speech processor, etc. Everything has to be turned off. Automatic gain control on your transceiver, AGC, should be off, or if your transceiver does not offer you options to turn it off, put it on fast. Radio frequency gain of your on your transceiver should be set so the, let me see previous. Okay. This indicator here, this green indicator, someone call it thermometer, is signal strength. It is set in the software, in the Windows, but further we can set it with the radio frequency gain. And it has to be between 30 and 60 dB. Because reducing radio frequency gain can help you with decoding weaker signals. Because when you reduce RF gain, you are reducing the noise. And sometimes it helps you to have better signal-to-noise ratio. And that is what is important. Not signal strength by itself, but the signal-to-noise ratio. And there is also one important thing, is automatic level control of your transceiver. That is a bit of problem, because, not problem, but it depends of the design of your transceiver. Because for some radio, for many radios, it should be set to show 0, nothing at all. But on some radios, it has to be set to show something. How much should be depends of the design of your transceiver, so it's better to consult your transceiver manual to see how much ALC should be set for the digital communications, for digital modes. Okay, we are not talking much about that because the time is running. It's better to try those things actually in the QSO. The important thing is that we make all the FT8 QSO on one dial frequency. We select one dial frequency per band, and that's it. On the software is this menu from which you can select the frequency. And the monitor button should be always green. That is important. It means that the software is decoding the receiving signals. Important thing is to find free frequency, black hole, before we are going to call someone, before we are going to transmit. We don't want to transmit over some other signals. So, you find black hole and shift left mouse button on the black hole. The red indicator is on the new frequency. And this is your transmit frequency. Never call a station on his transmit frequency. Avoid to do that. You may do that, but it's not recommended. Another important thing is to check hold TX frequency. When you find black hole and check that option, it means that you are free to change the receive frequency on the waterfall, but your transmit frequency stays on the chosen black hole. And that's it. And also, there is another option, somewhere here, not on this picture, auto sequence. It means when this option is selected, the computer takes the control of exchanging the messages. All is going automatically. So, when you are going to call a station, you click on the double click on the station you want to call, and the software generates the messages for the exchange. When you are ready to call, you click on Enable TX button. So it is a signal for the computer to start calling when the proper times come. On the 00 or 00 second in a minute, or 15 second, or 30 second, 45 second. Every 15 seconds. Let us define what the QSO is. Every amateur radio contact is an experiment in which we prove whether the radio contact between two places under certain condition is possible or not. According to a high frequency manager handbook of International Amateur Radio Union, a valid contact is one where both operators during the contact exchange three things: call signs, report, and confirmation. That is all we have to have for valid QSO. So how the normal QSO looks like, how it is going. For example, we see here ZS4 Juliet Alpha November calling CQ, and in the same message he is giving his grid locator, Kilo Golf 30. 9 Alpha 2 Juliet Kilo answer ZS4 JAN with his grid locator. ZS4 Juliet Alpha November accept the call from 9A2JK and answer with the report, -07. When the computer on 9 Alpha 2 Juliet Kilo receive this report, automatically send confirmation, Roger, received, and the report, -17. When ZS4 Juliet Alpha November received Roger confirmation and the report, he sends his confirmation, Roger, Roger 73. That is the end of the QSO. 9A2JK may send 73, and that's it. But what will happen if, for example, 9 Alpha 2 Juliet Kilo send Roger and -17 and don't receive RR73? The computer automatically send this message again and again and again until we received confirmation, or the operator stops, halt the QSO, because it is obviously at this moment the QSO is no longer possible, so it doesn't make sense for calling again and again and again. So as I told you already, the software knows which message to send next based on the previously decoded message. At the end, after the receiving confirmation, Roger, Roger 73, the software opens log QSO window and the operator manually log the QSO, clicking on OK. All this data for the QSO is already in the proper places for logging. Split operation in FT8. A split operation in FT8 is a bit different than in normal SSB QSO. But the split operation is not when we are set our transceiver on the black hole and calling the station on another frequency. That is a bit different thing. Let me explain. We always want to transmit in the sweet spot of our transmitter filter. It is somewhere in between 1500 and 2000 Hertz. For some technical reasons, we are not going to talk about that because it will take us a long time. But believe me, it is really important. So, how to solve that problem? You have to do nothing. The computer will do its job. So, for example, you want to transmit on 14074.8 kilohertz. So, your dial frequency is 14074.00. And your black hole is on the waterfall at 800 hertz. So your transmitting frequency is 14074.8. It's not in between of this. So the software change your audio tone to another frequency, let's say 1800 hertz, and change dial frequency 14073 instead of 74. And when you add these two numbers again, you have correct number you choose before. You are still in the black hole that you selected before. Why I'm talking you this? Because when you will operate on FT8, you will notice that when you're transmitting, suddenly your transmitter is not, the dial frequency of your transceiver is not 1474. Suddenly it is changed on 073. And you may panic, something is wrong, oh my God, what I am going to do? Nothing, it's all control. It has to be that way. And that is why. Because when we do that like this prevents signal quality issues. I mean, it is highly recommended. Let me not talk further about that because it will take too long time. Just trust me. FT8, the expedition mode, or someone call it fox and hound mode. Fox is the expedition, hounds are calling stations. This was made to make very fast QSOs. It is possible in this fox and hound mode, in ideal conditions, make up to 500 QSOs per hour. It is real big number, and this way give a chance to everyone to make at least one QSO, one contact with the DX station. Okay, this is ideal condition, but in reality it is normal to, in this mode, to have 350, maybe 400 QSOs per hour. This is still high number. And how does it work? Fox, DX station, is sending at the same time in one 15-second time slot up to 5 signals, one next to each other, up to 5, calling different stations, of course. Fox always transmit below 1000 hertz on the waterfall. And we, the callers, hounds, are calling up between 1000 to 4000 hertz even. And when the fox call us, we answer on his frequency, on the frequency of the fox on which the fox is calling us. So, because the reason is that we expect that this frequency is clear. And this frequency, many stations are calling one over the other, and the QRM and everything else. Problem with the coding. And all of this is going automatically. You have nothing to do. Just set up the software in Fox and Hound mode and work the QSO. This is how the standard Fox and Hound message looks like. You see, in one message, the Fox DX station, this is 4U1 ITU, answers two callers. Kilo 1 Alpha Bravo Charlie gives him confirmation, and 29 Alpha 2 Juliet Kilo gives signal report, -16. In one message. It is saving of time. And two stations in one message, 5 messages. It is 10 stations in 15 seconds. And normally, 9 Alpha 2 Juliet Kilo confirms report, Roger, and give a report. And that is the end of the QSO, because in the next message, 4U1 ITU will give Roger, Roger 73, 9 Alpha 2 Juliet Kilo has to do nothing, just log the QSO. Because when we got this, the QSO is over. We have just to log it. That's it. Full FT8, the expedition mode user guide, is on the internet on WSJT homepage, translated to more than 15 languages. So you just Google WSJT and it's easy to find. Some of the derivative programs have implemented the expedition mode in somewhat different ways, and it is not really real Fox and Hound mode. It is multi-stream mode. It is a bit different. You are making normal QSO, normal ways, but the other stations transmitted more than one signal at the same time. It's not real Fox and Hound mode. FT4. FT4 is similar to FT8. Also fixed length messages and so on, but FT4 is designed for contesting. FT8 takes a bit wider bandwidth of 90 Hertz, and for that reason is a bit less sensitive. But the messages, transmit-receive sequences, are 6 seconds long, much faster, 2.5 times faster than FT8. But okay, there is a price to pay for that. No, wider bandwidth equal more noise and less sensitivity. But FT4 is still has better sensitivity than RTTY. So probably it is a future of digital contesting. Maybe yes, maybe no, I don't know, we will see. PSK Reporter. It is a website. It's not a software for digital communication. But what is interesting in that? When you open that website, after you have a few transmission calling CQ or making a few QSOs, just put your call sign somewhere here, click go, and the new page will opens, And you will see all the stations that have received your signal. It doesn't mean that you have QSOs with them. It means just that they received your signal. And this is very useful information to know how far your signal goes. And how does it work? There is an option in software just to put check mark in that, and everything you received and the others also is going automatically to that website. Because we have to be connected on the internet for time synchronization. So we are losing nothing if we're sending this information. And there are plenty of other possibility for statistically see how this, how that. And finally, a few words about the Joe Taylor, the man behind this FT8. He was amateur radio operator since 1954. He's older than me. I was born 1955. And that led him to physics, to field of the radio astronomy. He was, let's say, professional radio astronomer, physicist, professor on, I don't know which university in the United States. And from the year 2000, he is retired. And he had enough time to develop, to use his professional knowledge to develop these software for weak signal communications. Now comes the important. Kilowatt Juliet Tango is Nobel Prize winner for physics. So he is not an ordinary person. He's still alive, thanks God. And he received the Nobel Prize for discovery of new type of pulsar, a discovery that has opened up new possibility for the study of gravitation, something to do with the Einstein theory of relativity and so on and so on. I knew nothing about that. But you understand, he was listening the space, the noise from the space, trying to find some irregularities in the noise. At the time when the computer was not strong as we have it now, he had no software, he had to write his own software for analyzing that data. So it's definitely, he's not won the Nobel Prize for nothing. And that's it. Thank you. Thank you.